Bismillahirrahmanirrahim. Now look at the example 4, page 290. Solve the initial value problem. Why it is called initial value problem? Because when your x here is equivalent to 1, then your y is equivalent to 2. So it means that you are given the initial value. Okay, so what you have to do first step is we need to write down this equation in general form. What you have to do is first you have to divide by x. So when you try to divide by x, so you will get dy over dx minus with the y over x is equivalent to 1. And then we compare with the general form. So when you compare with the general form, dy over dx plus with the pxy is equivalent to qx. Your px is actually equivalent to negative 1 over x, and then your qx is equivalent to 1. Then what is the next step? You need to find out the integrating factor. So mu is equivalent to e integrate with the px. So your px is negative 1 over x dx, or we can rewrite as e power of negative 1 over x dx. So you integrate 1 over x, so you will get e power of negative ln x, or you can rewrite as e power of ln x power of negative 1, and then it will become e power of ln x is actually equivalent to x. So in this case, your x is x power of negative 1 equivalent to x power of negative 1. Therefore, your mu is equivalent to 1 over x. Then multiply both sides with mu. So you have mu of the dy so you will have 1 over x dy over dx plus with the 1 over x then multiply both sides with, then the next step you will have d over dx 1 over x times with y, then equivalent to mu times with the qx. So your mu is 1 over x times with 1. Then what you have to do next is integrate both sides. So here dx will cancel up here on the left hand side. What left is 1 over x y is equivalent to integrate 1 over x, so you will get ln modulus of x plus c. Then your y is equivalent to, move x to the other side, so x ln modulus of x plus with the cx. Then you are given the initial point here. When your x is equivalent to 1, y is equivalent to 2. Then you need to substitute here to get the constant c. So your x is 2 is equivalent to 1 ln modulus of 1 plus with the c. So this one you will get 0. Then what left, c is equivalent to 2. So how to get the equation, the last equation? Therefore your y is equivalent to x ln modulus of x plus with the 2x. So this is your final answer. Now turn to page 291, class exercises. Look at to the question number 3. Solve the differential equation ln x dy over dx plus y over x is equal to x ln x. So the first step is you have to put in general form, dividing both sides by ln x. So you will get dy over dx plus 1 over x ln x y is equal to x. So this is your px, this is your qx. So your px is equal to 1 over x ln x. Then the next step, you have to identify integrating factor. Let mu is equivalent to e integrate of your px, so 1 over x ln x dx. So how to integrate this part? So let us put it here. So you have 1 over x ln x dx. So when you let your u is equivalent to ln x, therefore du is equivalent to 1 over x dx. So this one will become integrate 1 over u du is equivalent to ln modulus of u, then substitute back u with the x, so you will get ln modulus of ln x. So here you will get e power of ln modulus of ln x. Then by using properties, when you have e power of ln x, so it is equivalent to x. Therefore, when you have here e power of ln x, so what left is only ln x. Then the next step is you have to multiply both sides with mu. Ln x dy over dx plus with the ln x 1 over x ln x y is equivalent to ln x x. So for this part here, you can just simplify. So it is actually d over dx ln x y, then is equivalent to ln x x. So actually you can skip this step because this one just to prove that to differentiate mu of the y in order for you to get this. So no need for you to show this part. Then what you have to do next is integrate both sides with respect to x. On the left hand side here, what left is only ln x of the y is equivalent to, in order for you to solve this integration, you need to apply IBP. By using IBP, you have ln x of the x dx. So we let our u is equivalent to ln x, then du is equivalent to 1 over x dx. Then your dv is equivalent to x dx. Therefore, v is integrate your dv. Then you will get here x squared over 2. So uv, so your u is ln x. Your v is x squared over 2 minus with the integrate of the v du. So your v is 1 over 2 x squared. So your du is 1 over x dx. Then this one you can simplify. So what you will get, 1 over 2 x squared of the ln x minus with the 1 over 2. This one you just left x of the dx, then you integrate, you will get x squared over 2. So this one is x squared over 2, then plus c, then it is equivalent to 1 over 2 x squared of the ln x minus with the 1 over 4 x squared plus c. Therefore, our ln x of the y is equivalent to 1 over 2 x squared ln x minus 1 over 4 x squared plus c. So just simplify here. So we have our fraction here 1 over 2. This one is 1 over 4. So we can find out the common denominator is 4. Then 4 you can move to the other side. So 4y ln x is equivalent to 2 of the x squared ln x squared plus c. So this is your final answer.